Okay, good morning. My name is Harry Ricker. This is February 23rd, 2025, a cosmology group discussion meeting. Vladimir is going to talk to us about the JWST uh, observations, discoveries, and how they relate, how he's going to explain them using his world universe model. And hopefully this will be informative to people to understand what the new telescope, the famous James Webb telescope, is doing and accomplishing, and how it relates to cosmology. So, Vladimir, I guess we're ready to go.
Today's presentation is JWST discoveries explained by World Universe Cosmology. And at the third session of our meeting, we will talk about antimatter and form momentum. It's additions I've done yesterday after the Rogers presentation at our main meeting, let me tell you in such words.
Okay.
2023, renowned American theoretical physicist Michio Kaku in the video James Webb Telescope versus Big Bang Theory shared a stunning discovery made by JWST that changes everything we know about the cosmos and its existence. There have been 6 bizarre galaxies found that defy all explanation by the Big Bang Theory. It happens less than in 1 year because the very first results we have got in July 2022. 6 galaxies that are up to 10 times larger than the Milky Way galaxy are known after the Big Bang. These galaxies are changing our view of the entire universe. New observations indicate the presence in nature of large but compact galaxies teeming with stars much earlier than scientists had assumed, which are apparently incompatible with the current Big Bang theory. It is, in his words, the situation less than 1 year after the working of JWST. Later in November 2023, Michio Kaku proposed to dive into the mystery of the universe with, oh my goodness, the following question. JWST discovered galaxies they shouldn't exist before the Big Bang. How is that possible? Are our previous assumptions wrong? Are we discovering the limits of our knowledge, or perhaps even the answer to the question, what really existed before the beginning? He said, it appears that whatever we have been taught until now is not true. As joyous as we are about the JWST, it is also completely reshaping our understanding of space, and we know it. From rewriting history to discovering galaxies beyond our wildest dreams, with scientists panicking and wondering if everything we have believed has been a lie, we need to revisit history to get a better understanding. The advanced JWST is relaying pictures to us that show the universe in a completely new light. The scientific community is analyzing a wealth of JWST imaging and spectroscopic data from that era and is in the process of rewriting the astronomy textbooks. Look at his opinion after a little bit more than 1 year performance of JWST. And he's the honest guy. He cried. He cried. He is well-known scientist, physicist, cosmologist, and he cried. Let me close it. He cried about the situation in cosmology and astronomy at that time. James Webb Space Telescope. The 6.5-meter James Webb Space Telescope is 100 times more powerful than the Hubble Space Telescope and has already captured spectacular images of the distant universe. The telescope is working perfectly, delivering much better image quality than expected. Do you have any question, Ivan? Okay. A view
Hey,
of a tiny.
let me interrupt here and point out that this is an infrared telescope.
Yes. It's usually 4 micrometers. That's why, and everybody knows how to transfer to the visible images. I saw some special, two guys who is in charge of this transferring from microwave, from infrared radiation to visible radiation. There is a special program. They are doing their great job. That's why what we can see, of course, it's not the real images. A view of a tiny part of the sky reveals many well-formed spiral galaxies, some over 13 billion light years away. These observations challenge the standard Big Bang model, which posits that early galaxies should be small and lack well-formed spiral structures. JWST's findings are prompting scientists to reconsider the Big Bang model in its current form. Throughout the history of science,
Okay,
technological.
let me just point out what that means is that these galaxies shouldn't exist according to the Big Bang model because spiral galaxies, which is what they saw, shouldn't be there. They don't have enough time to form to be created. So there's the anomaly is that they shouldn't exist because it's according to current theory, it should take longer for spiral galaxies to form than is indicated by these findings of the telescope.
Much longer time. You're absolutely right. It's a billion years it must be. And we have spiral galaxies 300 million light years after the Big Bang. It's totally unacceptable for Big Bang model. Throughout the history of science, technological advancements have led to new results that challenge established theories, sometimes necessitating their modification or even abandonment. This happened with the geocentric model 4 centuries ago, and the Big Bang model may face a similar re-evaluation as JWST provides more images of the distant universe.
So it's been 2 years since um, what Keikyo said was in 2023, right? So it's been almost 2 years.
2023 November. It's a little bit more than 1.5 years, something like this. Yes.
And
That's why
they still haven't announced that the Big Bang is wrong. So
they're not announcing. They're keeping silence. Who cares about crying of Michio Kaku? Who cares about crying of Penrose, Cox, and some other well-known cosmologists? Who cares? They have their grants, they have their money, they continue all this bullshit.
well, he's not the only one who's talking about this. There's other people who've
Told
been
you,
talking.
even Penrose, Nobel Prize laureate in physics, the beginning, Big Bang was not the beginning of the universe, his opinion. Cox, he has the same opinion. A lot other guys, Sabine, Alexander Unziker, and a lot of other guys, they against it. They're keeping silence. Everything is okay. There is such a saying, dog is crying, elephant is passing in Russian. I don't know, do we have such American sayings? But yes, this elephant continue his walk, and that's it. So simple like this.
I
Let's
have you
continue
guys.
our talk today for this. But thank you so much for all these comments because it should be discussion. It should not be some official lecture or something like this. Harry, thank you so much for your comments. Distances to remote objects other than those in nearby galaxies, are nearly always inferred by measuring the cosmological redshift of their light. An important distinction is whether the distance is determined via spectroscopy or using a photometric redshift technique. The spectroscopic redshift is conventionally regarded as being necessary for an object distance to be considered definitely known, whereas photometrically determined redshift identify candidate distant sources. For comparison with the light travel distance of the astronomical objects listed below, the age of the universe since the Big Bang is currently estimated as 13.787 with so good accuracy, take a look, plus minus 0.20 billion years. Below, we discuss macro objects with redshift more than 10. Experimental findings, 2022. It was immediately after, July 22, they started to observe the universe. I will talk later about the most distant galaxies with spectroscopic redshift determination. HD1, at that time, it was the furthest. Then judges Z13, Z12, Z11. I will talk about them later in my discussion. Let me pay your attention to the light travel distances. It's about 13.6, 13.5 billion light years. It is 300 million light years after the Big Bang. Can you believe it? They exist, and all of them spiral galaxies, by the way. Let's continue. Notable candidates for most distant galaxies. The most impressive, of course, it is F200DB045 with redshift about 20.4. It is observed photometrically only. If it will be confirmed, and it still didn't confirm, it will be light this travel distance more than 13.7 billion years. It will be about 100 million years after the Big Bang. It's totally unacceptable for them. Okay, let's continue. We'll talk about these galaxies a little bit later.
Well, let me go back here. I talked about this before. Go back to this. These numbers, these catalog numbers, are very confusing. They don't really have kind of like you've got the F200 DB and you got CEERS and you got a S5, and you've got all these different catalog designations. And this is kind of confusing. I wish they'd come up with some kind of standard, put it all together rather than have all these different catalog designations. But that's where these names come from, these catalogs. They do a survey, and then they give it a name, an object a name in the survey, and then they go back later and measure the properties of it. Okay, let's go on.
But let me give you my opinion about these candidates galaxies. You know what they found already? 2 years passed, and there is no any confirmation for any of these galaxies. Can you believe? Because it's against them. They don't want to admit it. You see, they don't want to confirm it spectroscopically. And what is important, it passed more than 2 years and no news, no any observations, no confirmation of these candidates' distant galaxies because they're against their theory. For Big Bang model, it's a killers. They are killers. Let's continue. They presented experimental results 2022, half a year only, observation, show that HD1 is one of the earliest and most distant known galaxies yet identified in the observable universe. HD1's unusually high brightness has been an open question for its discoverers. It has a significantly more luminous ultraviolet emission than similar galaxies at its redshift range. Can you believe it? It's unique. F200DB045 is a candidate high redshift galaxy with an estimated redshift of Z20.4. If confirmed, it will be one of the earliest and most distant known galaxies observed. These galaxies would have a light travel distance, look back time, of more than 13.7 billion years.
Okay, let me interrupt you again. What do you mean when you use this word confirmed? What is that? I mean, they have a
Microscopically,
measurement. First off, they have a measurement Z equals 20.4. So that applies to me that they made a measurement.
photometrically, and they want to see the whole spectrum. This is different. You have different bands, and you can compare one band to another one band to another one. And they know, oh, it's not enough. We must have the whole picture and to compare all the wavelengths in the spectroscopically observations. That's
Well,
why they
I've seen some of the papers where they actually have done spectroscopic measurements, and I think they do have some spectroscopic measurements. Maybe not for these particular ones.
Yes, for HD1 spectroscopically, and even the latest one, I will talk about Z14 a little bit later. I will talk. They right now, maybe months ago, they released a new, the furthest galaxy with Z equals 14. I don't know where they will start to talk about Z20, Z more than 20 even. That's why,
That's
for them,
extraordinary.
I'm sorry?
That's an extraordinarily high redshift, 20.
Yes, and they don't want to accept it because, as I told you, these galaxies, they are killers for them.
Have they tried doing a deep field view like Hubble did yet with the James Webb? I think that they're going to find if they even try, they're going to find stuff even older.
Well, that's
I
what he's talking
absolutely
about. They
agree with
actually,
you, but unfortunately, I cannot manage these observations. I'm very sorry. If you can do, please do it. I will be more than happy to see new results. Recent experimental findings 2023-2024. Ely, Pauling, and Fries in the article Supermassive Dark Star Candidates Seen by JWST wrote, the first generation of stars in the universe is yet to be observed. There are two leading theories for those objects that mark the beginning of the cosmic dawn: hydrogen burning population 3 stars and dark stars made of hydrogen and helium but powered by dark matter heating. We show that each of the following three objects, JWST, Z12, and Z11, with redshifts in the range between 11 and 14, are consistent with a supermassive dark star interpretation, thus identifying for the first time dark star candidates. It's unbelievable. This idea about dark star candidates, I predicted in 2013. 10 years later, Fries and co-authors of her, they claimed that this is the very first dark star candidate. Even the title, Dark Star, I put 10 years ago. Unbelievable. I sent all of them my papers. Who cares about my papers and my model? They have the very first dark stars candidates. Unbelievable.
what do they mean by
I
dark star? What does this mean? Dark star. What does that even mean? To me, it's all just incomprehensible jargon. Hydrogen burn. Well, I know what they mean by population 3, but that's, if you don't know, then it's
these
just jargon.
stars made of helium and hydrogen. That's it, nothing else. But there
Well,
is
what they
no,
mean is first generation stars. So the Big Bang
they named
happens.
it population 3. Yes, it's a first stars made of helium and hydrogen only. But you need to heat it up, to warm it up, and they don't know how to do it. That's why they invented these dark star candidates. It means for me that inside there is some kind of dark star, and we don't know what does it mean, dark core. And there is something helium and hydrogen around as an envelope, I don't know. I don't know. That's why you ask them. I don't understand. But what is important? Even the definition dark star I put 10 years ago. Because dark star, in my understanding, is dark core made of dark matter. And then you have some shallows around, some envelopes around, some layers around. This is dark star. And I put this picture 10 years before. But who cares? I don't care about the title. I do care about the essence of the model. And this population 3 star heated by dark star candidates, I have no clue what does it mean. You see, that's why I put their own words. I don't responsible for any one of them. It is exactly their opinion. A new record, JWST discovery of JADIS Z14 pushes the earliest galaxy ever seen to just 290 million years after the Big Bang. This new record holder is remarkably unexpectedly bright. 1 point. 5 times brighter than the prior JADIS Z13 record holder. 5 times. JADIS Z14 is even shockingly visible to Miri's eyes, means the instrument of the JWST infrared instrument. But this galaxy is extremely dust poor. All their galaxies, stars made of dust, and the extremely dust poor. It's visible, clear. The lack of dust inside of JADIS Z14 present a novel puzzle. No, it's okay. With Big Bang model, it's okay. Look, all this, it's only one record now, JADIS Z14. So many questions, and there is no any answers of the orthodoxies of Big Bang model. Sorry for my emotions, Of course, I'm tired of all this bullshit, but what we can do about it? Continue. Abundance of and brightness of early galaxies. Contrary to predictions, JWST has found that early galaxies forming just a few 100 million years after Big Bang are more numerous and brighter than expected. This discovery implies that star formation in the early universe may have been more efficient or occurred in intense bursts. Exactly my point, intense bursts. These findings challenge existing models of galaxy formation and evolution. I will talk about later. Discovery of the earliest and most distant galaxies. JWST has identified galaxies dating back 300 million years after Big Bang. These galaxies, JADIS Z14, Z14 0, Z14 1, are significantly more massive and luminous than anticipated, suggesting that large galaxies formed rapidly in the early universe. These unexpected observations by JWST are prompting astrophysicists to revise their models of the early universe, galaxy formation, and black hole growth. Let me remind you guys, there is no name the first time it's about black hole. All the galaxies, according to Big Bang model, have black holes inside of the core of them, like in our Milky Way galaxy. We have a black hole. Where is the time? Where is the material? Where is the matter to organize this black hole? Because the way how to arrange these black holes to have some explosions, supernova, something like this, and so on and so on. But you have only 200, 300 million light years, billion years. How to arrange not only galaxy itself, but the core of the galaxy made of the black hole? The question immediately, where it came from, these black holes? How? Sorry, one more very big problem with black holes for their cores. JWST has spectroscopically confirmed numerous galaxies at Z more than 10. Hilton et al. Report photometric detection of the most distant spectroscopically confirmed galaxy, Z14. The most plausible solution for the stellar population properties is that this galaxy contains 500 million masses in stars with a strong burst of star formation in the most recent few million years. The inferred properties of Judges Z14-0 suggest rapid mass assembly and metal enrichment during the earliest phases of the galaxy formation. It's a total killer. You have already metals. It means heavy elements in this star. There is a rate of the raising these masses so huge, they don't know how to explain it. That's why, I'm very impressed, especially with this record. This record, it's only 0 equals to 14.3. What will be with Z20.4? I have no clue.
Okay, according to their theory, in order to have metal enrichment, you have to have stars have to form from helium and hydrogen, then they have to burn out and go to supernovas, and then the supernovas have to spread the heavier metals created in the interiors of the stars. And then you have to repeat this process several times in order to get metal enrichment. So to have metal enrichment in very early stars completely destroys their theory.
Absolutely right. I didn't want to talk about these details, but you're absolutely right. But the most important, at the same time, you must arrange your black hole. Don't forget about black hole. Where is your black hole?
That's another
How
problem
metals you
because
have? I know you're absolutely right. But black holes, where is the time for arrangements with black hole?
well, they have to form presumably by all these supernova explosions, and then the gas gets swept into the black hole. So the black hole has to take a very long time to form because you have to have all these stars form and explode, and then other stars form and explode in order to get the black hole. So there's your problem. Okay, go on.
It's not a problem. It's a bullshit, problem. Problem, you can solve it. There is no time for it. It's simple like this. Thank you so much for these details because it's exactly what I expected from you to give details for the other people to understand what's going on with their model. And they're keeping silence. They continue have their money from grants and continue their investigations. Very important issue. In 2018, I proposed a new picture of the world, 4 years before the JWST. Let me read
Okay, let me interrupt you
the
here.
claims.
There's like not enough time really to talk about this slide. We only have 4 minutes.
We can continue with what was before, but what is important, I reserved 2 sessions for discussion of this JWST, and then the last one we will talk about, antimatter and form momentum. Because I was very excited about the Rogers presentation yesterday, and I promised him, I was in a green room at that time, and I promised him I will give you the answers on all these questions tomorrow in my meeting. That's it, simple like this.
Okay.
If you have
So
any
before
questions,
we
let's
get
finish. Yes.
okay, go ahead. But remember, you're going to get cut off.
We can continue talking about what is existent, what Orthodox is talking, if you have any questions or details. Or I can talk about my predictions 4 years before JWST, and then I will continue. Let me name it, and that's it. JWST discoveries confirm the most important predictions of WC in 2018. Absolute age of the world is 14.226 billion years. I stress that this absolute age I calculated based on experimentally measured value of gravitational parameter only. You don't need any other phenomenon, explanations, evaluations. No, it's a really calculated with accuracy of the gravitational parameter measurement value. The second, dark invisible epoch spanning for Laniakea supercluster from beginning of the world for 0.44 billion years, when only invisible macro objects made of universe created matter form and evolve. It's very important. We have extra 500 million years before so-named Big Bang model. We can do a lot of work before with so-named universe created matter and universe created macro objects in this dark invisible epoch. Luminous epoch ever since 13.787 billion years for Laniakea supercluster, when luminous macro objects, supercluster, galaxies, extrasolar systems emerge. Transition from dark epoch to luminous epoch is due to explosive rotational fission of overspinning surface speed at equator exceeding escape velocity, UC matter superclusters cost, and self-annihilation of universe-created particles. Macro objects of the world form from the top superclusters down to galaxies and extrasolar systems in parallel around different cores made up of different UC particles. Finite, boundless world presents a patchwork quilt of different luminous superclusters, which emerged in different places of the world at different cosmological times. Let me stop at this moment. If you have any questions to these steps, but what is important, I put all this picture 4 years before JWST. And you will see how the results, the observations of JWST, you can put on my picture easily, because you have additional 500 million years, you have some explosions, you have, first of all, your supercluster, and the superclusters, they can give the birth to galaxies, stars. It's like a firework, it's explosion. That's why at the very early our luminous epoch, we have already these galaxies formed because it was an explosion. All of them were generated at once. But what is important? Milky Way galaxy, it belongs to Laniakea supercluster. The whole Laniakea superclusters must be at that time already, because Milky Way galaxy even has an age equal to the age of the universe. It means not only Milky Way galaxy, the whole Laniakea supercluster with 100,000 stars already must be in business. You see what does it show of the world? I put in 2018 as a new physics. I put all this dark epoch, luminous epoch, absolute age of the world, and all this stuff, guys. Let me tell you, it was 4 years before JWST. And I'm so happy, one more time. In 2013, I've done some prediction and they were confirmed in 2015-21. But now, 4 years before JWST, I put this picture, and now I have a confirmation of this picture by their observations. And only my model can explain all these unique properties of the world around us.
Okay, now you kind of went pretty fast over the
Let's read one
Linnea.
more time.
What you're, and this is I've tried to point this out before. Your theory seems to be similar to the Lemaitre idea of this exploding, super dense
No,
object.
no,
Well, now you said that.
no, Harry, no. There is no matter at the very beginning. The beginning was 14.223
I didn't say it was the
billion
same. I
years.
said it was similar. So you're saying that these universe created matter objects that appear at the beginning, they must appear at the beginning, right? some universe created object must be created at the beginning.
Beginning for 0.44 billion years. We have dark epoch. During this time, we can collect all this matter. 500 million years, we have collected all the matter from the universe as universe created matter, universe created particles. We at this time we built our so-named universe created matter and macro objects made of universe created matter only. You see what I mean? But
So
we have
this is
additional 500 million years.
all right. Okay. So what you're saying is that I find this a little bit confusing here about the terminology.
And what is important?
So when the universe is created, there's this, well, at some point,
okay.
This isn't really clear what you mean by dark epoch and luminous epoch and and these macro objects. When do the macro objects form? And what are they? What are they formed from?
Okay, let's continue. Let's read one more time with details. Absolute age of the world, 14.226 billion years. It's calculated based on experimentally measured gravitational parameter only. There is no other words, only experimentally measured value. Dark invisible epoch spanning from Laniakea supercluster, because our Milky Way galaxy and all these measurements around us belongs to Laniakea supercluster from beginning of the world for 0.44 billion years, when only invisible macro objects made of universe created matter form and evolve. What is your question about it? There are only macro objects made of universe created matter form and evolve, because we must have explosion, but not of a point like Lamartine. Superclusters, it's a huge objects with size, I can give you it's 10 to the power maybe 23, 24
Okay, so
meters. It's a big
the breaking up doesn't occur until the luminous epoch.
luminous epoch, it's when it started, emerged, when it was this transition, it was explosive rotational fission of overspinning surface at equator exceeding escape velocity. You see matter supercluster scores. When you rotate the superclusters with so high speed that you started to lose part of it, like volcanoes. You have volcanoes on the surface of these superclusters cores made of UC matter. You see matter only. You have luminous epoch and luminous matter and ordinary matter as a byproduct of UC matter self-annihilation. You see, you have no luminous before because you must have explosion, you must have a firework out of this huge supercluster cores with all the galaxies around, and there's the galaxies give stars. Even in the Milky Way galaxy, we have a star with age about the age of the universe, and only then around each core you see matter core, you have this heating evaluation, you have this enrichment with metals, with everything. You gave the birth to all the luminous objects at that time. You gave them core heater, and this evaluation will go with shells around. You will saturate them with the new metals, with the new compositions, and so on and so on. That's why this transition, like as I told you, the best picture is firework. But firework of this invisible, from the beginning, invisible parts of this supercluster, huge rotating universe created matter cores. And you created all these cores at once. The whole Laniakea supercluster was arranged at once with all these different pieces for different galaxies, stars, and all this stuff. And then they started to grow up immediately because you have a very good reactor. You see matter reactor. Smiling, James. I do like your smile. You like my picture.
Well,
Okay.
that's the
Can I continue, Harry?
biblical version.
Okay,
I'm
so the
sorry?
fireworks don't start until the luminous epoch. And the
Yes.
fireworks is what connects to the Lemaitre model.
Yes, it's exactly the point. You know, you have your firework and you arrange all these cores around at the same time. And then you started to grow up each core independently, separately, all of them unique. No one repeat another one. No, they have different size, different, you know, the compositions and all this stuff made of universe created matter. That's why, guys, I want to be sure that you will understand my main picture because you will see later the JWST observation. They are very good to confirm this picture. It's exactly my point, and it was only 4 years before GWST.
But the beginning
Please
of the
continue
luminous
asking this question.
epoch, sorry, just kind of, the beginning of the luminous epoch coincides with what is conventionally conceived of as the beginning of the universe.
I put even their number 13.787. But what is important? It's not absolutely true. I will tell you why. Because we have not only one supercluster core in this invisible dark epoch. No, we have more of them. And not every one will explode at the same time. There was no big bang when all exploded. It might be one supercluster exploded today. Tomorrow, 100 million later, will explode another one. They have independent the thousand at least this supercluster. We have right now evaluation about more than 1,000 luminous superclusters. But they started with these superclusters course long ago. It was maybe, you know, that's why I put this number. For me, it does matter. 13.787. It's like a comment to show the difference for Laniakea supercluster that it is 0.44 billion years between my age of the world and accepted by Big Bang model age of the universe, of the Big Bang, whatever it is for them. And for me, if it will be 13.8, 13.6, it does matter. It does matter because it does matter that there is about 500 million years before all this firework. You have so much to do with this universe created matter to arrange all these huge macro objects and what is important to rotate all of them. To rotate, because nobody talking about this rotational angular momentum. Many times I told you guys. And what is important, experimentally, astronomers already proved that all of them rotating. You know, they are crying, astronomers, they are crying. All our galaxies rotating. We can measure it, and so on and so on. But how it happens, nobody telling you. That's why this course of superclusters made of universe created matter, it's not only source of your matter or the cause of these galaxies, it's the core of rotational angular momentum. You can take this rotational angular momentum from supercluster core and share with all the galaxies around, with all the stars around. And let me remind you, in our Laniakea supercluster, 100,000 galaxies, and all of them rotating. They're elliptical, they're spiral, whatever. How it happens? That's why this firework, it's only the one picture to arrange the whole supercluster. Let me tell you, it's not separate galaxies. These 100,000 galaxies in supercluster, Laniakea supercluster, belong to it. They're moving around the center, so need great attractor. There is a center of it, a great attractor. All of these galaxies, 100,000, moving around this attractor. It means that the whole picture, the whole supercluster, luminous supercluster, must be arranged at once because Milky Way galaxy cannot start without this great attractor. Great attractor. It was the beginning of supercluster. I mean, in this dark epoch. And luminous epoch, when this supercluster exploded, but it's not was explosion. Let me tell you, it was volcanoes. Volcanoes. All the surface of this supercluster were covered with volcanoes, and these volcanoes put all these cores made of universe created matter around. Galaxies, 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 everything at once. You see, it is very important to stress that we are not talking about arrangement of galaxies. We are talking about the whole supercluster, and nobody even talking about it. That Milky Way galaxies, I showed you this picture many times. It's already 10 years existent, Laniakea supercluster and Milky Way galaxy with the age equal to age of the universe belongs to it. And there are the 100,000 galaxies. Please give me the idea how to arrange all these supercluster at once, at the same time. This is exactly what I proposed. Let me remind you one more time. 4 years before JWST. That's why even I put my first paper about JWST, confirmation of my predictions. You see, it was a confirmation. I was so happy not only to see these pictures, I'm so happy about it, but to have a confirmation of the picture of the world I proposed 4 years before. What your questions, guys? It's a very important step. Let's please ask me these questions. With smiling, without smiling, I will be more than happy if you will have another idea how to arrange all the galaxies at once, how to provide them with rotational angular momentum, and how to see all these different galaxies at once. One more time. Whenever you are looking, you have something different, and they're so bright, so much UV. They're enriched already with metals and all this stuff. Guys, it's everything against standard Big Man model. And it's exactly can be explained only inside of this picture. I gave it to you right now.
All right, we'll continue on.
Okay, let's go, guys. Because it is a very important step in my presentation right now. Because I will show you that how it works later. WC explanation of JWST discoveries. Latest observations by JWST on the world can be explained in frames of WC only. It is a question of time. The beginning of the world was 14.226 billion years ago. Dark invisible epoch, when only UC matter macro object existed, lasted for 0.44 billion years. Luminous epoch has existed ever since 13.787 billion years. It's my first critical point. First of all, if you don't have time, please find the way where to this time. And I gave this time, guys, for JWST 4 years before this started to work. You have this time to evolve your so-named dark matter course. Now I may name this universe created course. Early galaxies formed in near-present configuration as the result of transition from dark epoch to luminous epoch due to explosive volcanic rotational fission of overspinning UC matter supercluster cores and self-annihilation of UC particles. Ordinary matter is a byproduct of UC particle self-annihilation. There are no proto-galaxies in the world. That is why JWST did not see their images. They tried to find proto-galaxies, something small, something practically invisible, and so on. No, instead they have these galaxies 10 times bigger than Milky Way galaxies, much brighter 5 times, and so on and so on. It's a shock for them. It's a shock. Compact Dix galaxies emerged because of the rotational fission of the overspinning UC matter core of superclasses. Each of them have one UC matter core. There were no frequent mergers of galaxies in the early epoch. They expected, they expected small galaxies, and then they will start emerging, and only then you will have some bigger structures. No way. There is no merging. No, they didn't see even two galaxies going together. No, they're separate. According to standard cosmology, massive, mature disk galaxies with mass up to 10 to the power 11 mass of the sun cannot form for the time 100, 400 million years because it takes billions of years to form them. So they should not be there at all at the beginning. Can you believe it? We hope that all these candidate galaxies with high redshifts up to Z more than 20.4, light travel distance more than 13.7 billion years, will be confirmed. It depends on their spectroscopical confirmation. This is what I'm expecting from them. Maybe in 5 years, maybe in 10 years, they will do it. I hope I will survive this time. Continue. We emphasize that now with JWST we are looking for the earliest and most distant galaxies, and at the same time we live in one of the earliest galaxies, Milky Way. Milky Way, the age of Milky Way, close to the age of the universe. It's accepted by orthodoxies, but it's not only Milky Way, as I told you. Additional 100,000 galaxies around, they have the same age as the Milky Way. Contrary to Ilya, Pauling, and Fries, who consider JWST Z13.0, JWST 13.12.0, and JWST Z11.0 as a supermassive dark stars made of hydrogen and helium, but powered by dark matter heat, we see them as galaxies with UC matter cores, which are UC matter reactors providing heating of them. In WC, there are no black holes. It's a very important difference between Fries and her team and my understanding of all these galaxies. In our view, the unique observations of galaxies JWST Z14.0, lake of dust inside, star formation in the early universe may have been more efficient or occurred in intense bursts. It's exactly their opinion. I proved it. Yes, it was a burst. Significantly more massive and luminous than anticipated. Rapid mass assembly and metal enrichment during the earliest phase of galaxy formation. Extremely massive galaxy candidates have been identified at Z more than 7 in much larger numbers than expected. Population of ultra-massive galaxies account for 20% of the total cosmic star formation rate density. Can you believe it? Supermassive galaxies, more than 20%, can be explained by macro objects formation process proposed by World Universe Cosmology. In detail, we discussed about this formation of galaxies, stars, and all these objects, luminous objects we can see right now in frames of my model. Do you have any questions? Please ask them right now. Let me continue. Thus, for this session, conclusion. World Universe Cosmology aligns with all fundamental concepts of the cosmos, offering a robust framework for understanding primary cosmological parameters and their interrelationships. The model enables precise calculations of values that were previously determined only through experimentation, while also making verifiable predictions. The striking agreement between its calculated values and observational data reinforces confidence in the model's validity. The remarkable experimental results and astronomical observations of recent decades should be examined through the lens of WC. Rather than claiming to fully explain all existing cosmological data or presenting a complete theory, WC serves as a foundation for a new cosmology echoing the vision proposed by Paul Dirac in 1937. While ongoing refinement of the global physics community remains essential, the insights of World Universe Cosmology, combined with the groundbreaking discoveries of the James Webb Space Telescope and the enduring legacy of Dirac's ideas, underscore the urgent need for a paradigm shift in astronomy, cosmology, and classical physics. World Universe Cosmology calls for recognition. This is the end of the presentation I prepared for you guys 1 week ago. And last two, I'm a little bit tired. 2 slides I will show you maybe next session. It's about our four. Sorry for my emotion. About antimatter and for momentum. Let's relax. Let me relax it because I put too much emotions. That's why, look, I will continue next session, but I'm ready to answer all the questions about this picture, about the observations of JWST. Right now, each month, we have hundreds of new papers about new observations. I'm so happy about the results of astronomers. They're doing a great job. I am not talking, oh, cut all these astronomical, measurements and observations. No, I'm talking about the explanation of them, confirmation of them, the picture of them, the analysis of these results. This is my point. I want to do obsolete Big Bang model. It doesn't work. It's time to cancel it, to reject it, to throw away this Big Bang model because it doesn't work at all. And they're still convinced that it's okay. Orthodoxy will continue to grab their money from the government and our pockets and will continue all these explanations. I don't know what kind of explanations, but they don't have any explanations. I couldn't find any new ideas from orthodoxies of Big Bang model. How to explain what they can do. They keep silence and that's it. Oh, you can cry. It's up to you, Michio Kaku and all the other guys. We don't care about you. This is the understanding of the situation. How to change the situation? How to start this initiation of this, at least discussing these new ideas, new the alternative cosmologies. There is no way. I tried all this time to send my letters to all of them crying, guys, take a look. I gave you a new picture of the world free. No $1 I spent on it. And you have, guys, millions of bucks for nothing. Sorry for my emotions one more time. I will relax a little bit and then next session, I will give you two very important with orthodoxies. That's why I cannot stand it. I want to talk about this antimatter and for momentum at once next session. How much time will left for this session, Harry?
Well, we got lots of time, I think. That's relative.
That's why,
probably
it's
15
very good
minutes.
time for you for questioning, because I don't want only to talk about, to discuss. I want your questions. I want your understanding in details of my picture, how it works for JWST observations. Do you have any questions? For me, the most important part of these discussions is your questions. How to answer your questions, and maybe in the future some other smart guys will ask the same question and I will be prepared to answer them.
I have some points which might be helpful.
Okay, James, as usual, with interest, I'm waiting for your questions.
Well, first, I wouldn't necessarily apologize for being emotionally involved in your work, as you often apologize, because that emotion, I think, is the energy which allows us dissident workers to pursue our goals, and all the sweat and blood and tears that we shed in doing our work over many years. And so I wouldn't apologize for that. And I have a few
So
other.
much. I'm sorry. Thank you so much. Unfortunately, you're absolutely right. I exhausted, but this is my nature. I developed this cosmology for 24 years, and still I have a lot of energy to proceed with it, to cry and to ask, guys, please take it. It's free. Please continue. I'm sorry. Yes, it's
Okay,
my mother nature to be emotional.
a few other ideas that may be useful. You talk a lot about the beginning. I'm quoting here little fragments of what you said: the early universe, the absolute age of the world, the Milky Way age, and so forth. It seems to me that you might actually use the information that you've gathered and presented here and previously as well to argue that this whole idea of the redshift determining the age of signals received by our telescopes and other equipment that we use is in fact false. That this redshift is being misinterpreted, and it seems like what the data that you're actually presenting is maybe the foundation to argue the reverse, if you will, that that this is a false idea, that this observed redshift is actually telling us the age of anything. That other processes such as tired light, as Ian Cohen has mentioned, or I mentioned, Compton scattering as changing, reducing the energy of light signals and so forth. So I just wanted to bring that up as something that may be helpful to you.
Let me make a comment for you. First of all, James, you're absolutely right. You're absolutely no redshift. There is no blue shift because it's not only redshift. There are blue shifted. 8,300 galaxies, Gupta, he named in his paper. What to do with our neighbor, Andromeda? What to do? It's a blue shifted galaxy. How
hold on, Vlad, hold on, take a rest. You've presented, but you say the red ships don't exist in the blue and yet you spend a great deal of time talking about them. In a way, the listener might surmise that you're actually questioning the validity of the red ships, and I just bring that up as something that might be helpful. Another helpful idea in my little notes here that I took, if I may, is that you talk about this volcanic eruption idea. I may not be having the right phrase for it, but I think your credibility might increase a bit, sir, if you were to cite some material physicist, experimentalist type of data. Like, for example, haven't people studied spinning objects like spinning wheels, spinning tops, that occur, for example, in engines and motors and so forth? And at what point the amount of spin is so great that they actually break apart and the parts fly apart? Like you can imagine, like let's say we have a bicycle wheel that is spinning at a certain point where it's spinning so fast, the angular momentum in there is so great that the wheel just sort of blows apart. Isn't that a phenomena which is well known to physicists, and a phenomena that you can look up and actually cite, because you just say this occurs? But if physicists have actually studied, for example, a spinning piece of bread, I think, will break up into little pieces with relatively low angular momentum compared to a spinning piece of iron. You see the point I'm making? I think this is something.
Yes, I know.
I think this is something that materials specialists have studied, and there might even be tables in the handbook of physics and so forth on the ability of different materials to withstand angular momentum, or excessive amounts of torque being applied to them before they actually start to break apart, because this is a very practical consideration in actually for engineers and actually designing something. Is my material going to be able to withstand the amount of spin that it will have in the machine or the motor or whatever that I'm creating? So not to talk so long, I just wanted to say that your credibility might be increased by citing this sort of data that probably exists. It might be in the handbook of physics. Our material scientists would have this. Certainly engineers would have this. And rather than just sort of postulate out of the thin air volcanic fission, eruption, or whatever the exact terms you use, which just seems like you just sort of dream that up, rather than saying, physicists have worked on what you're talking about, Vlad. They have done this, and they've worked on that. And if you cited them, I think there'd be more credibility, because otherwise people say, well, what is he talking about? Volcanic eruption? And are there volcanoes on the surface of black holes? Or what is he really talking about here? If instead you just cited this sort of material and work that engineering people have no doubt done, the credibility might be increased. And a last point, if I may.
Well, let me answer your question. One sec. Last point you will tell. First of all, this effect, well known even for kids. For kids, there is such a game that's such a fun for kids. Imagine you have a round disc plate, sitting kids on this disc, and this disc started to rotate faster and faster and faster. Who is the winner? Who will stay on this disc, the last one?
Exactly.
This effect well
Right.
known for kids. That's why you don't need to refer to anything. Man, kids, you can see any part with such a plate rotating, and the last one will be the winner. Oh my goodness, how they're trying to hold themselves, because there is nothing to hold for one. It's a plane. That's why, it is a well-known effect for kids. Hopefully, orthodoxies, they know this kids' game. Okay, next one.
Exactly, the spinning platform in playgrounds.
Playground. That's it, simple like this.
As a excuse me, sir. Go ahead if you want to talk more.
No. I only commented to your very good proposal, but it's a well-known effect.
Right, and I think you should cite that.
Maybe.
Rather than, because I don't recall you ever actually citing that.
Yes, you're right.
Okay, the last point that I have, or maybe there's two more, I have plagiarism listed here in my notes. If you in fact sent some papers to people who then published material, or words like, I think you said dark something, dark star or dark whatever, that you had written about and sent this paper, and you have the records of your sending this paper to a particular person who then used your terminology without giving you credit, I think you should shout out plagiarism to those people and even to their superiors. I'll just leave that. I won't even ask for your comment, but I just point that out. Lastly, money from grants is something that you talk about repeatedly in a certain context. I just wanted to point out that one can go to various government websites, including the National Science Foundation, plug in the names of, you mentioned Penrose or other names of whoever, plug in the names of various people and find out exactly the amounts that they have received in the past and what they're receiving in the present. And that would then provide you with detailed information on actually calling these people out for defects in their work as you see it. And I'll rest my comments there. Sorry if, but I'm just trying to be helpful to you. Thank you.
So much for this help. Let me only give you some information. I published already in the same journal for 10 years, 38, and now accepted the last one, 39 articles. Each of them I sent to all of them. I have at least 10,000 respondents, expert in this business, cosmology, astronomy, and so on and so on. No one answered, no one, never. And I published for 10 years. I sent all the time to them without any response. They don't care about my work, my model, my results, articles. Who cares? That's why if I will tell them, oh, you named dark stars, I named it in 2013, who cares? They don't want to see anything from myself. I
But the point
uploaded on.
you've made this point before, Vlad, and you've said it again now. But I'm going further. I'm saying for any one of these people that you've sent your material and you find then later a publication which frankly is plagiarism of a phrase, a name, a process, or anything in your papers, that those people receiving your work previously that you can document, that is technically plagiarism if they don't give you credit, if they don't cite your work. And you can go on various social media like the new version of Twitter, which is X, or wherever, and or even go to the chairmen of the departments of these particular persons and raise a question as to the integrity and honesty of these people. And there, I think people are going to start to pay attention. They will have to, because plagiarism is considered to be a serious issue, and people have lost their jobs when that has been shown that they were plagiarizers. That's my point.
You're absolutely right, but I don't believe that I can achieve any objective to blame them, to do something with them. I want to be positive. Instead of blaming them, I'm asking, please, at least take a look at my model, at my articles. There is no way. They will not even open this window.
Does anybody else have any comments or questions? I see that Vladimir is taking a break.
I'd like to delve a tiny bit further, if I may, into this coincidental value for the beginning of the epoch, according to Vladimir's model, and the beginning of the Big Bang, conventionally given. I mean, in the latter case, what they do is well, according to my thinking, they assume that the red shift is a Doppler shift, and they assume a linear relationship between the red shift and the distance of the object from which the light is coming. Both, according to me anyway, erroneous assumptions. But anyway, if you take those and you extrapolate the thing back, this linear value back, you get 13.8 thousand million years ago. Now, so they're based on erroneous assumptions, according to my thinking. But I think it's rather strange that Vladimir's beginning of this non-dark epoch, in other words, the end of the dark epoch, coincides almost, to the third place of decimals with this value that they give as the beginning of the Big Bang. So perhaps Vladimir might indicate, the origin of his own value in a little more detail. Did you get all that? Because you came a bit late into.
I can do it. I asked for my presentation. Okay, let's continue. Share. Sorry. Okay. Let me answer the question. I gave you the number of digits after the comma, after the point, according to the measurements of gravitational parameter with this accuracy right now. It's simple like this. I'm not talking about something extra. There is a correspondence between experimentally measured value with this X, with these 3 digits after the comma. I give the age with the same accuracy. That's it, simple like this. Can you hear me?
I think he's asking about how do you calculate the difference between the beginning and the start of the luminous epoch. So how do you
Yes,
calculate the dark
yes,
epoch
yes.
time?
Yes, first of all, absolute age of the world depends on the gravitational parameter only. Simple like this. I calculated 0.44 billion years only because I took their value. And immediately after that, I gave you the comment that all superclusters can emerge in different time. It's only for Laniakea maybe this time. And for me, it doesn't matter because I have extra 500 million years before so-named Big Bang. Simple like this. I don't care about 13.78777 because they did put additional 10 million bucks right now or 10 million years. That's why instead of 0.45 billion before it was, now it is 0.44. It's accordingly. I changed 10 million light years accordingly to their evaluation of the age. And I don't know, they calculated this age where, how they did it. I don't know. And what is important, I told you already, I don't care about Z. I put in my tables only as astronomers referred to these galaxies. For me, this JWST much better telescope because it's 100 times more powerful than Hubble. It's very important because it means if you have your better instrument, you can see further. You can see galaxies which you didn't see it before with Hubble. Simple like this. That's why how far away? I don't know. I don't know when it was happened, this transition. Everything depends what supercluster you're talking about. Because not all only one, the other one, they started to explode to have this volcanic activity at the same time. No, no, there can be different time. Many times I told you, all these superclusters they are different. They emerged in different places at a different time. Simple like this. And how to calculate it, I don't know. And for me, in my model, it does matter. I need only extra time. That's it. This is I'm sure. Because first of all, this course, very huge course of classes must evolve to have grow up, to rotate faster and faster before it will happen.
So is it correct to say then, Vladimir, that you calculated this 0.44 thousand million years based on the gravitational parameters, in your model, and that you've merely added that to the conventionally accepted view of the beginning of the universe and got what you call the beginning of the world, and that the beginning of the luminous phase was not calculated independently by you, but you've added your independent
No,
value to that. Is that not correct?
it is correct. It is correct. But what is important, the procedure was a little bit different. First of all, I calculated absolute age of the world, like you have absolute temperature, Kelvin. There is absolute zero. The same story, absolute age of the world. I calculated based on gravitational parameter. And I got this 0.4445 when I subtract this accepted by orthodoxist number. It will be different number. It will be a little bit different number difference between absolute age. This is a constant, stable, standard. And then whatever they will tell luminous epoch started, I subtract from my absolute age, then value, they will accept. That's simple like this. That's why it is very important, the absolute age of the world based on And the only one gravitational parameter we have measured on my Mother Nature. I can calculate Hubble parameter, all the cosmological parameters based on gravitational parameters only. Age of the world, temperature of our microwave background radiation, all these parameters, I talked many times on them, all of them interchangeable. You can go from one to another one. They are connected to each other, through my equations, very simple equations. That's simple like
Well,
this.
just one more point then, clarification, because you've possibly dealt with this in previous talks. But just quickly, Vladimir, do you accept a linear relationship between redshift and distance away from us?
No, I don't know anything about redshift because I have 8.3 thousand blue shifted galaxies and there is no meaning. The next very important point, you can talk about supposed supercluster, our Laniakea supercluster inside, and I will tell you my understanding. But you have another supercluster. If you will go to another supercluster, it will be totally different story. Let me give you the analog and you will understand my understanding. We have our solar system. We have planets going around our sun. Very good one. And anytime you have some planets, if you're sitting on Earth and looking for other planets, anytime in your system, solar system, you have some planets going out from you, and there are some planets going to you. Some of them blue shifted, some of them red shifted. The same story with galaxies. They're rotating like planets in our solar system around center of supercluster, great attractor. That's why you can find any correlation between galaxies. It might be blue shifted, it might be red shifted. There is no meaning for it. In this picture, what I gave you right now, guys, is with planets. So, look, Venus, it's going to us right now or out of us. Mars, it goes to us or out of us, of Mother Earth. It's the same story with superclusters. The same. Superclusters, their behavior like a solar system, analog solar system. Blue shift, red shift. It depends on position of each planet in our solar system. The same story with galaxies. This is a Hubble tension. Remember, I explained this way Hubble tension. Guys, what you talking about? Everything depends. You're looking, this galaxy, it's moving to you. This galaxy, it's going out of you. And all of them going around the same center of our supercluster. Simple like this. That's why there is no problem with it. That's why, they put these values. It's okay. It's only for them to say how far away they were with this particular galaxy. But if you will go to some other galaxy, it will be blue shifted. And what are you going to tell about? It means that there is not zero, but negative distance between Earth and Milky Way galaxy and other galaxy. No. Blue shifted galaxies.
You counter, do you? Just clarify. You counter the view that the preponderance of galaxies are red-shifted, and the blue-shifted ones would be exceptions. And we calculate by various means, say Cepheid variables. We calculate the distances, and hence we get some sort of relationship that increasing redshift and increasing distance, whether it's linear or not. So do you counter all that? Do you dismiss all that technology?
I have no control on it. I don't care. Because solar system, this is all our world. It's a patchwork of these superclusters. That's it. We live in our supercluster. By the way, maybe sometimes I will talk about some bigger superclusters at least 2 times. Okay, it doesn't matter right now. It will be maybe next my talk about these superclusters, cosmic bubbles, and all this stuff. I have such a plan maybe in a couple of weeks to give you some idea. That's why, everything depends. We cannot tell anything about the distance between galaxies based on this red shift, because blue shifted, they're far away from us, but they're blue shifted. It's against common sense. I'm so sorry. And you know why it's happening? It's happening because of Big Bang model. All the galaxies started from one point, so named initial singularity, and all this flying around. But unfortunately, some of them, Andromeda, they're going to us. Why? It may be like a Venus, it goes to us right now. The same story, Milky Way galaxy and Andromeda moving to us. And in a few million years, it will be combined with Milky Way galaxy. Unfortunately, we will not see this event. Sorry.
It seems like are you using the redshift to determine the early universe or the absolute age of the universe or the beginning? I'm just quoting from you in today's talk. Do you use it for that?
No. First of all, age of the world of universe doesn't depend on Z. The second very important.
What does it
I put
depend
the
upon?
Z. Age depends on the only on gravitational parameter only. That's it. I told you guys. I don't care about Z, blue shifted, red shifted. I don't care. There is no such even notion in my model. There is no Z. Linear, non-linear. My understanding it's non-linear, but they count it's linear. It's up to you guys.
Well, it might be
Okay,
interesting.
let's move on.
It might be interesting to know how you calculate the age of the universe from the capital
In
G.
my papers, I showed you. Guys, I showed you the previous talk. If you will see the equation, how I measured it. Based on gravitational parameter, I calculated dimensionless parameter Q. Then I multiplied on unit of time, T0, and I got this, age of the world. Simple like this. Based on gravitational parameter, I calculate the dimensional parameter Q. That is, by the way, this is a Dirac number. And then based on this Q, I can calculate all the cosmological parameters. No problem. That's why I know. Z is only for astronomers. And for me, bigger Z means it's further because Hubble, it couldn't see this galaxy. Now with this new instrument, JWST, we can see them. For me, it means they're further. That's it. And how far away? I have no clue. I don't know how they're moving around which center of supercluster. It moves moving to us or out of us. I don't know anything about it. That's why we cannot put any value on this parameter. There is no such parameter in my model at all. Sorry, maybe let's continue because we have two issues to talk about it. And it was some questions yesterday about antimatter and for momentum. And James, you asked this question. I want to answer you. By the way, guys, we have only 5 people in here. I invited twice 3,000 people, 20 people, I don't know how many, to come to hear about my model and about these questions about antimatter and for momentum. And we have only 5 people. We have 3,000 dissidents and interest in my work, only 5 people, including myself. That's good. Why I'm talking about? And you're talking, James, to send these letters with my articles, 40 articles, who cares, to all these guys. Nobody even have an interest in our society. Very respectful dissidents. And where are they? It's frustrating me, guys. We are talking about cosmology, and I'm so happy to see all of you because you are interested in this cosmology. You have some interest in alternatives, and you have very good questions to me. But where are the other guys? Where? I'm so sorry for this emotion.
We are having some discussions about this, with regard to the CNPS generally. With David de Hilster, and I might say that on the Saturday sessions, we again only have half a dozen regular people really participating, through the green room. Now, admittedly, we do have quite a number of people just participating, and I don't want to dismiss that, but most of those people are just casually looking at the the matters, and not many of them are very knowledgeable. I think they're interested in having conversations between themselves, which is fine. I mean, I welcome that, but I think one of the problems is we all have our own pet theories, and we're all somewhat in contradiction with each other, and we don't have one general message to convey. So it is a problem, and what we're seeing at these cosmological sessions is really just a mirror of that general lack of interest, if you wish.
You see, but my understanding was when Harry started these meetings, educational purpose. People, they can find something new for them if they have a curiosity only. They don't have even curiosity. It's frustrating me. You name yourself dissidents, you have some alternative technologies, cosmologists. Please come to our meeting and talk about your technology, your cosmology, and all this stuff, guys. That's why I'm really frustrated. I don't know what to do with my model. You know, I have so many people. I sent so many letters. Do you know how many responses I don't have? How many letters I sent? Over 90,000 for 10 years. 90,000 of them. And what is the result? Nothing. Nothing. This is the most important. Physics in crisis. People, they don't have interest in physics at all. They don't have interest in universe, in our solar system. They don't have any interest. I don't know what their interest is and why they name their dissidents. No, I don't know.
There were annual face-to-face meetings, you know, the CNPS or the NPA before that. This is before I got involved. I haven't attended any of them. But I tend to think that they would have been useful maybe in getting people together. And perhaps they did result in, you know, the core membership, the core people who get involved, and you know, even some of us perhaps introducing us together. Now, those SENA DA meetings have been cancelled, you know, for basic reasons. I mean, I suppose it was the COVID and that, and maybe modern technology, which we're availing ourselves of at the moment, and so on. But you know, it would be useful if you, for example, and others thought that that would be one means of maybe getting, you know, the interest resuscitated and getting more people involved. You know, I personally, I think I'm using them very much, these, you know, online systems, these Saturday and Sunday sessions, and they're very enjoyable. But personally, I'm beginning to doubt whether they're sufficient.
You know, please, Ian, you're a very important person. Please talk to managers, to all the guys in our society about the situation in our meetings, in your meetings, in Roger's meetings, in Harry's meetings, you know. Talk to Nick, maybe he's a director of this society, because, you know, I don't know what to do. But if there is no interest inside of our society, how I will raise this interest in my work outside of our society? You know, at least I had some hundreds of people. They share at least my understanding. They can support it. Then I can cry. The whole society, they are on my side. They suppose that I have a reasonable different guess cosmology. No, 5, 6 people always. That's it. Harry, Nick, Ian, you, Roger, guys, you're the principal guys for our society. Please cry to our president about the situation. Maybe he's paying some money for all this stream here. Huh? I'm sorry.
He's been working on that for a long time, and I think he's just as frustrated as you are. Let's move on to the antimatter.
Let's move on, guys, because, you know, it's frustrating, but, you know, whatever it is, I'm so happy to see at least 5, 6, 7 people at most we have right now in our meetings. And this education, it seems to me that at least after today's meeting, you will better understand my picture of the world, because we are talking. It is not a lecture. It is a discussion. It's a talk. I do like this frame of our meetings even, you know. It's like, you know, talking around the kitchen table. I like kitchen table, you know. Okay, let's continue because I promised you to talk about the two more issues. Antimatter. Let's go. Antimatter. The antimatter problem is because of the Big Bang model, which is obsolete. There is no Big Bang model. There is no this problem. Simple like this. Simple, guys. It's invented by Big Bang model, this problem. There is no this model. There is no this problem. Oh, come on. According to the World Universe Cosmology, the universe is continuously creating different stable universe-created particles, 4 fermions and 3 bosons. Ordinary stable particles, protons, electrons, photons, and neutrinos are the byproducts of UC particle self-annihilation. There is no antimatter. In my model, there is no antimatter. In Big Bang model, there is, and there is a problem. In pi, there is no antimatter. We can see positrons in some other particles. Let me explain you how. When powerful gamma quants with energy at least 1.02 megaelectron volts in the vicinity of atomic nuclei can produce electron-positron pairs with high concentration. These collisionless, unmagnetized electron-positron plasma are very well studied. You see, we have gamma quants with a very high energies. You can produce all these ordinary particles, including positron and some other of them, as a result of gamma radiations, gamma rays, gamma quants in the vicinity of atomic nuclei. They can give electron, positron, they can emerge. Proton, antiproton maybe emerge too if you need more energy, but we have gamma quants up to 10 energy to arrange this antimatter. But it is a result of gamma radiation produced in my metal as a result of self-annihilation of UC particles. So simple like this. Last year in the presentation, high energy atmospheric physics, it was a special talk, you know, 1 year ago. I discussed in detail many experimental results, including the following: ball lightnings and many of them. I named only 2 of them. Thunderstorms create electron and positron beams. Beams of antimatter positrons produced above thunderstorms on the Earth. You know, it is a funny story about satellite. It has some counter gamma quants, counter measurement tool. They try to see gamma planets and stars outside of the Earth. And suddenly they started to get these gamma quants from the beneath, from the Earth. They was frustrated. How come? Nobody expected it. You see, that's why I told you about this. I don't want to repeat this talk. It was 1 year ago. But what is important? Antimatter is a result of gamma quants that are the result of self-annihilation of UC particles. Simple like this. I don't tell you there are no positrons. There are positrons, but the generation of these positrons is the result of a gamma quants, and we have plenty of them with a totally different 18 orders of magnitude different in energies of these gamma quants. You can, with these gamma quants, you can generate everything, all the table of periodical table of elements, everything, because you have your tera electron volts, you know, maybe you see particles with tera electron volts energy, and you can produce whatever you want if you have gamma quants with such an energy. It's horrible. It's huge. What do you have any questions about antimatter? First point is very simple. There is no such problem. In my model, there is no antimatter. You can generate antimatter in our world as a result of gamma quants. That's it. Simple like this. If you have any questions, if not, let's continue with 4. Okay. For momentum, it was a very interesting talk by Roger yesterday. For momentum, square these values, that values, and so on and so on. When I heard it, I was totally frustrated. This, let's start from the beginning. All particles are fully characterized by their four momentum with four components, E over C, Px, Py, Pz. That's the equation. But what is important? This equation, E over C squared minus all these components in squared. Why squared components? Because 3-dimension, 3 momentum is a vector. And you want to find the total momentum as squared components summarized, and then take root square of this value. If you have some squared numbers, it means immediately it's a vector. That's why when yesterday they talked about the squared energy, it's a bullshit, because energy is scalar. You cannot talk about squared energy. It's very, very important. We can rewrite this equation the following way. What I've done. This is the first component here, P total squared, and these 3 squared parameters, components of this momentum in our 3D, plus additional P4 squared. What does it mean, P4? Let me stress. Then in these equations, this subtraction invariant. And somebody invented this MC squared. Who is this somebody? Einstein or somebody else? I don't care. Why they've done it? Because if you will put the overall 3 momentum 0, then you have E over C squared equals to MC squared. Then you will find E equals MC squared. Simple like this. We invented the first parameter, EC over C squared, MC squared. We took it to give this MC squared Einstein equation. Come on. That's why what I've done, I retitled these parameters. First of all, the first parameter I put P squared total, that equals squared components of our 3 momentum plus the force components that depends on our, let me continue, where P total equals E over C and P4 equals MC. Scientists invented these components without any reason. We stress that all particles of the world have so-named rest mass m, which is in fact the characteristic of the force component of the 4 momentum due to the expansion of the nucleus of the world in the 4th spatial dimension with speed c, that is the gravitodynamic constant. You see what I mean? All of us, all the components together, we are sitting on the surface of this 4-dimensional nucleus of the world. This 4-dimensional nucleus world is growing up with speed c, according to my model. If we are sitting on this world, we are moving together with the surface at the 4th dimension with the same speed c. That's why we have our additional force component of this vector, 4 momentum vector squared, mc. Whereas m, we introduce, it's convenient for us to have some number because we have this force momentum component, and we want to name it as we accepted it in our real life in 3 dimensions. That's we put MC. It's convenient for us. What is important? All the experimental parameters for elementary particles, for all these interactions, all this they give not mass of the particle. They always give energy. I ask the question, why you're measuring energy? We are talking about of the particles, measuring energy. My understanding in my model, The particles, they don't have energy. They don't have mass. They have only four momentum. And energy you can put as the total energy in this equation. It's your understanding, but it's not the real why. Because, as I told you, for momentum, it should be vector. Vector must follow this Pythagoras equation. These four components of four momentum, which is a vector, summarized according to the Pythagoras equations. As a conclusion, in WC, all particles are quantum objects, which have only four momenta and have no rest masses. We invented this, and that's it. That's why all this talk yesterday about the squared values of energy, why they summarize. James, you propose, oh, you're right, absolutely right. The total energy equals this energy plus rest energy and so on. And we can do it. But in this equation, there is no such equation. It's a different story. You propose different equation, and I agree with him. But if we are talking about four momentum, let's talk about four momentum. And four momentum, it's a vector in a four-dimensional space. And the four-dimensional space means it must be the fourth component, spatial component of this space. And then you can measure this total squared four momentum as a squared parts of each component, as it must be according to Pythagoras equation. Simple like this. You can use it now easily, and always with vectors, we have this equation, simple like this. No conflicts, no stories. Many times I told you, we have a quantum objects, we have four momentum only. That's it, simple like this. And this is equation for this four momentum. And I gave a new even understanding of this equation. Equation means only you have momentum only, vector. There are four components, and you hold four squared values of these components. That's it, simple like this. Do you have any questions about four momentum?
So if we're on the surface of this hypersphere, presumably we're moving at velocity c. Does that mean that we have no rest mass?
Only fourth dimension of our four momentum. We don't have, no. It's vice versa. We have four momentum only, fourth momentum. If we will put for particles, I'm talking about particles right now. If we will talk, and we consist of particles, if you're not talking about each particle, it's exactly this equation. That's why quantum objects is a particles. For particles, we can put this equation MC, and we can talk about rest. No, it's only fourth dimension momentum. Oh my goodness. Sorry, one sec. Too much emotions, and I have I'm so sorry. That's why mass, there are no masses of particles. Mass, accordingly to my model, it's classical notion, classical. It's ensemble of particles. You have your mass because you have ensemble of particles in your body. Simple like this.
Well, I think there was a bit of confusion, I'm sorry, yesterday. I mean, here you say the so-called rest mass M, but if you're talking about the conventional view, perhaps M0 would be the way to express that. So if you have the expression E squared equals what you had yesterday is MC all squared plus P squared. And I think Roger said, oh, when P is 0, you get E equals MC squared. No, that's not true. The equation is only true when you have M naught in there. So E squared is equal to M naught C, I think, all squared plus P squared, which is equal to MC squared, where M is the converted mass, according to the main theory. So we just need to...
I put M as a usual standard because M0, M, it doesn't matter, because it doesn't exist for particles. I'm so sorry.
Fine, but your equations are consistent then. But yesterday, the equation was interpreted incorrectly. It was said that M naught is the same as m. So in other words, E equals mc squared was only true when p equals 0. Well, that's incorrect, really.
Yes, let me tell you about the mass. We have three different masses. Let me remind you. There is a gravitational mass for classical physics accordingly to Lesage mechanism. There is inertial mass for the second Newton's law. And there is a rest mass for particles. Which one is correct? What is the relationship between them? There is no any sense between gravitational and inertial mass. And this is a key point for the general relativity. Gravitational mass, inertial mass, the same. Absolutely wrong. Two different stories. And the same story with the third story.
Okay,
with
we're
mass
coming
of
up to
particles.
the end. We're coming up to the end. Got a
Okay.
quick 10-second summary.
Summary, very important. Thank you so much for coming. I'm so happy you have your curiosity in something new. I'm so happy to report to you about the details of my model. And it seems to me I achieved my main goal for today. You have better understanding what I'm talking about, and you asked me a very good question. Thank you so much for coming. Hopefully, we will continue to talk with you to have different discussions in the future, but hopefully we will be joined with some other dissidents. I hope to see a little bit more people around because it's very educational, our discussions, and maybe they will find something new for them too. Thank you so much, guys, for coming. Have a great day. And I was so happy to be with you today.
Okay, well, thank you for doing your presentation, Vladimir. And we'll look forward to people next week.
Let's see what will be next week. I hope that it will not be. I can give you my talks not every week, at least every 2 weeks, because I've done already at least 9 talks with Ian, at least 5 talks in here. That's why I have some experience and